Jai Shyam friends, today we shall discuss about lecture number 7, which is electric charges and fields. And the topics for today's discussion are electric charges and its properties and certain numerical problems we shall discuss. Now, first of all, what is electric charge? Electric charge is a property of matter that causes it to experience a force when placed in an electric field. Then there are two different types of charges. One is positive, and other is negative charge. Okay. Now, like and unlike charges mean like charges repel each other, while unlike charges attract each other. These are the basic things about electric charge. Now, some more points about electric charge. The SI unit of electric charge is in coulombs, or you can say ampere second. CGS unit is electrostatic unit of charge, that is ESU of charge for stato coulomb or stat C. Okay, so 1 coulomb is equal to 3 into 10 raised to 9 stat coulomb, which is also equal to 3 into 10 raised to 9 ESU of charge. Next point is electromagnetic CGS unit of charge, that is absolute coulomb or electromagnetic unit of charge EMU of charge. 1 coulomb is equal to 1 by 10 of absolute coulomb, that is 1 upon 10 of EMU of charge. Practical units of charge are nothing but ampere hour, which is 3600 coulomb, or you can say Faraday, which is equal to 96,500 coulomb. Okay. Now we shall see on the properties of electric charge. Now, charge is basically a scalar quantity. Number two, it is transferable. Then it is always associated with mass. Then charge is quantized. Further, charge is conserved. It is invariant. It is accelerated charge, which radiates energy, and similar charges repel each other while dissimilar attract. Now, see what is the meaning of quantization of charge. Q is equal to NE, as we know. This Q is the charge, total charge, N is the number of electrons, which is always an integer number, could be plus minus, but E is electronic charge. So you can have charges like this: 2e, 10e, 5e, 500. Means these are integer numbers. Means 1.5e, 2.7, 13.7. Like these numbers are never possible. So this is what is the meaning of quantization of charge. Next is, if charge moves, means it is constant. Unlike mass, so Q is not variable; it is constant. Now Q, you can say it is constant but not variable. But in case of mass, which is variable, if the velocity of mass is comparable to the velocity of light, then it increases. Okay, so if the charge is at rest, then it creates only electric fields. If charge is moving with constant velocity, means acceleration 0, then it creates both electric field as well as magnetic field. And if the charge is accelerated, means v is not constant, then it is creating electric field, magnetic field as well as radiation. Quantization of charge, as we have already discussed, the quantization of electric charge means the total charge Q of the body is always an integral multiple of the basic quantum of charge, that is Q is equal to NE, which is where N is equal to 0, plus minus 1, plus minus 2, plus minus 3, up to so on. Okay. Now see one numerical problem. Two metallic spheres A and B of mass m each are given plus Q and minus Q charges respectively. Then we have to select out of these four options. Okay. Now, as we have already discussed, if the charge is positive, means its mass decreases, means the electrons are donated to some other. So means positive charge means mass is decreased, while negative charge means mass is increased. So option A is correct. Right. Next one is, a small charged ball having minus 1 microcoulomb charge is charged with another identical charged ball B. If the charge on each after separation is plus 2 microcoulomb, then the initial charge on B is okay. Now see this. This is an initial setup. Both A and B, one is having minus 1 microcoulomb, and another is having say Q charge. After they are kept in touch, then the redistribution charge results in 2 microcoulomb each on both the balls. So Q initial is equal to Q final. As I have just told you, charge remains conserved. Means you can say minus 1 plus Q is equal to 2 plus 2. So this is Q is equal to 5 microcoulomb. So this is how we can solve the problem. Okay. Now another problem: if a body gives out 10 to 9 electrons every second, how much time is required to get a total charge of 1 coulomb from it? Okay. See, number of electrons given out by the body in 1 second is 10 to 9, as given in the problem itself. So charge given out by the body in 1 second is equal to n into E. Okay. Number of electrons into the electronic charge, that is 1.6 into 10 to minus 10 coulomb. Fine. Now the time required to get a charge of 1.6 into 10 to minus 10 coulomb is 1 second, right, as per the question. Now time required to get a charge of 1 coulomb means that is 1 upon this. Okay. Unity formula, this 1 upon 1.6 into 10 to minus 10, that is 6.25 into 10 to 9 seconds. Okay. So you can say this is seconds. Now if you want to convert this into years, so that would be 198.18 years. Okay. About 200 years. Okay. So this is the final answer. So we can say finally, from a body emitting 10 to 9 electrons per second, it will take nearly 200 years to get a charge of 1 coulomb from that body. This shows how large is 1 coulomb and the unit of charge. So this coulomb is very large unit of charge. So this is about today's video, friends, and we shall see you in the next video. Till then, goodbye. Jai Shri Ram.